Okay, so today we'll be doing the question 12. Um, so, firstly, you need to consider the vertices A, B, C of the rectangular prism shown. So, there's A, B, C. State the coordinates. So, for coordinates, you always do X, then Y, and Z. So, to start off, coordinates A. So we take a look at where it's positioned based upon the x-axis. So that would be 1. Next would be the y-axis. So that'll give you 3. And then finally the z-axis. And since A isn't along the z-axis, it would be at 0. Next for B, take a look along the x-axis. So for the x-axis, it's at 0. So B would be 0. Nextly, y-axis. So over here, it's along the 3. And then finally, z-axis, it's along 2. And then lastly, out of these 3 coordinates for C, so up here, x-axis, 1, y-axis, along the 0, and positioned at 2 for the z-axis. Okay. Now for the next part of the question, part B, we'll need to find the unit vector n with the little hands on top. So to do that, first we need to find n, and to find n we'll need 2 vectors in the plane containing a and b, so a, b, and c. So first we need to find AB, which would just equal B minus A. We can get that from the coordinates, so for B it would be 0, 3, and 2, minus coordinates for A, 1, 3, 0, and we'd be given -1, 0, and 2, even though you can't tell. Next one would be AC, just like AB, given it by C minus A. So for C, 1, 0, and 2, minus 1, 3, 0, and we'd be given 0, -3, and 2. Now, using these 2 vectors, we'll get n by timesing the two together, so AB times AC, which also equals -1, 0, 2 times by 0, -3, 2, as we found earlier, which also leads to the most annoying part. So when timesing the two vectors, you'll need to use A2, which would be 0 in this instance. So coordinate of A in the second position, so 1, 2, 3, A2 times by B3 minus the alternate version, so A3 times by B2. And the next would be A3 times by B1 minus A1 times by B3. And then finally, A1 times by B2 minus A2 times by B1. The most annoying part of it, so we'll need to substitute, so that would equal for us 0 times by 2 minus 2 times by -3, and 2 times 0 minus -1 times 2, and lastly -1 times -3 minus 0 times 0. And after doing all of that, should be given new vector 6, 2, 3. So that will give you n, but not done yet because still need to find n with the hat on top. And to get that, we'll need to do 1 over magnitude of n times by n. So that would equal 1 over square root 6 squared plus 2 squared plus 3 squared times by 6, 2, 3. So after doing all of that, should be left with 1 over 7, and we leave the 6, 2, 3 as is. So that would be our value. Next, we'll need to verify that it is perpendicular to AB. And to verify that, we need to make sure that the thing is that the dot product between the two is equal to 0. So 1 over 7, 6, 2, 3 dot -1, 0, 2. Now for dot product, it's much more simple. You just times the two things on the end and then add them all together. So 1/7 bracket. So 6 times 1 is -6. 2 times 0, that gives us 0. And 3 times 2, 6. So add them all together. That just leaves us with 0. So 0 times 1/7 equals 0. Therefore, it's true. And finally, part D, we need to determine the Cartesian equation for the plane that contains A, B, and C. So for that, we'll use vector n, so 6, 2, 3 that we had earlier, and A, which found at the very beginning, so 1, 3, 0. So to get the equation, we need to do R dot product n equals A dot product n. So R is just x, y, z, then dot product 6, 2, 3. It looks like a 7, but that's a 0. Equals 1, 3, 0. Dot product 6, 2, 3. So as stated earlier, dot product is just times them, then add them all together. So 6x plus 2y plus 3z. And then dot product of a and n. So 1 times 6, 6, 6 times 2, 6, 0 times 3, 0. So equation would be 6x plus 2y plus 3z equals 12. Can bring the 12 over if you wish, but not necessary in this case. At least I'm lazy. And that's all you need to do. Thanks for listening and dealing with the really poorly drawn things.